Hi everyone, this is Mrs. Jackson. This is Chapter 4, Section 4, Part 1. And in this section, we're going to get our first look at what rational function graphs look like, specifically the reciprocal parent function. The reciprocal function maps every non-zero real number to its reciprocal. And that function looks like f of x or y equals 1 over x. All right, so let's take a table of ordered pairs and graph them, see what this looks like. So if I put in -10 for my input, then my output is going to be -1/10, and I'm going to use decimals just so I can fit it in the box better. Likewise, -5 for my input would give us -2/10. -2 would give us -1/2 or -5/10. -1. Now recall that if I have 1 over -1/2, if I divide by a fraction, that is the same thing as multiplication by its reciprocal, so that'll turn into -2. And 1 over -1/4 is going to give us -4. Of course, we cannot have a 0 in the denominator, so this is undefined here. And then you're going to see symmetry when we put in the positive numbers, although it'll be the opposite sign. So we'll have 2, 4, 1, 5/10, 2/10, and +1/10. So these are our values that we're going to graph. So it can be a little bit tricky graphing numbers like 1/10 and 2/10, but we'll do our best. So I'm going to do the positive numbers first. At x equals 1/2, our output is going to be up at 2. I'm going to have to zoom in here. At x equals 1, our output is 1. At x equals 2, our output is 1/2. At x equals 4, we would be at 1/4. And all the way down to 1/10 over here. And at 1/4, we're going to be up at 4. So if we take a look at this, this is very smooth, no sharp edges. And as we approach x equals 0, our output is going to get larger and larger. And as we approach positive infinity on our input, our output is going to get increasingly smaller. And we're going to have symmetry on the other side. Specifically, it's going to be a reflection over the origin. So at -1/4, I'm going to be all the way down here at -4, at -1/2, I'm going to be at -2, at -1, I'm going to be at -1, -2 at half, and all the way over here at -10th, I'll be at -1/10. So you're going to get a symmetrical looking curve that is symmetrical over the origin. Let me try to graph that line of symmetry. It's a little awkward given the scale that I put on this graph, but it's basically the line y equals -x. So it'll go through the origin and it has a -1 slope. So it looks something like that. Let me see if I could put a line to it. Something like this. So these two pieces of our reciprocal function in red are basically symmetrical over that yellow line. Okay, let's talk about the domain and range. So the questions I posed: do you think the graph will intersect the x-axis? Why or why not? And likewise, do you think the graph will intersect the y-axis? Why or why not? Hopefully you can see the trend here on our graph. The answer, the quick answer on both, is going to be no. As we get more and more positive on the domain or more and more negative on the domain, our graph is going to infinitesimally become closer and closer to that x-axis. but it's not going to touch that x-axis. So if we were to put that in symbol notation here as x approaches positive infinity, our output is going to approach 0. However, it won't ever touch it. Likewise, as we go more and more negative, you can see our graph is coming closer and closer to that axis. Also, x cannot equal 0. We cannot have a 0 in the denominator, but as we're approaching that 0, so we come smaller and smaller and smaller on either side of that y-axis, our output is either going to trend very, very large or very, very small to positive infinity up in quadrant 1 and negative infinity over in quadrant 3. So this brings us to a very key definition, and it's also part of one of our unit's essential questions. That is, what is an asymptote? So this key term here is part of our essential questions, asymptote. It's pronounced with a silent P, and an asymptote is a line that guides our graph, and our function continually approaches that line. But it never actually touches it or crosses it. Now that is always a true statement for vertical asymptotes. There are a few instances where a horizontal asymptote can be crossed, but we are going to talk about that in another section. So let's first talk about our horizontal asymptote in the reciprocal parent function. So you can see here our horizontal asymptote is the x-axis. Both in quadrant 1 and quadrant 3, our red curve is approaching that axis, but it's never actually going to touch it. But it certainly does guide the end behavior of this graph. So if we were to describe that x-axis, actually let's first write it. It is the x-axis in green. The equation for the x-axis is y equals 0. If we look at what our vertical asymptote is going to be, you can see that it's going to be the y-axis. So that is going to guide our graph, the range basically. As we approach that axis, our range is either going to be trending towards positive infinity, or our output is going to be trending towards negative infinity. So our vertical asymptote is the y-axis, and the equation of the y-axis is x equals 0. And so if we look at the domain and the range of this parent function, we can see that our domain is all real numbers essentially, with the exception of 0. X cannot equal 0. Likewise, our output is also all real numbers, except that our output cannot equal 0. So this introductory video on our first rational function is called the reciprocal function. And we've also introduced this new term called asymptotes, which are going to be a critical part of all of the rational functions that we look at going forward. I hope this video helps. Thanks for listening.